Problem 11.2 asks to find the angular momentum of this particle right here relative to points D, E, F, G, and H. The formula for angular momentum is L equals R cross product P. And the formula for the cross product is Ry times Pz minus Rz times Py. That's for the x component. And then Rz times Px minus Rx times Pz for the y component. And Rx times Py minus Ry times Px for the z component. So, to find the angular momentum relative to point D, it would be the distance from the particle to point D, well, from point D to the particle, which is -4 in the x-axis and -5 on the y-axis. So it would be -4, -5, 0, and then cross product 10, since it is on the x-axis, 0, 0. And then using the formula for the angular momentum for the cross product, it would be Ry times Bz, which is 0, minus Rz, which is 0, times Py, which is 0, so x component is 0. For the y component, it would be Rz, which is 0, so 0, minus Rx, which is -4, times Pz, which is 0, so another 0, so the y component is 0 again. And then for the z component, it would be Rx, which is -4, times Py, which is 0, so 0, minus Ry, which is -5, times Px, which is 10, so it would be -50, which gives us 0, 0, and then a positive 50 in the z component. Kilograms times meters squared per second. Now we have to do the same thing for point E. So at LE, it would be the distance from point E to the particle is just a +5 in the y direction. So R equals 0, 5, 0, cross product 10, 0, 0. Using the same formula for the cross product, we get Ry times Pz, which is 0, minus Rz, which is 0, so 0 in the x-axis. And then for the y-axis is Rz, which is 0, so 0, minus Rx, which is 0, so another 0 for the y-axis. And then for the z-axis, we get Rx, which is 0, minus Ry, 5, times Px, so we get -50 kilograms times meters squared per second. We do the same for point F. Now point F is +4 on the x-axis and -5 on the y-axis. So R is 4, -5, 0, cross product 10. Now this is pretty much the same as the point D, except for a positive x value. So we know that the x and y component are going to equal 0. And then for the z component is rx times py, which is 0, minus ry, negative 5, times px. So it gives us a positive 50 kilograms times meter squared per second. Now for point G, the distance is positive 4 on the x-axis and 0 on the y-axis. So R is 4, 0, 0, cross product 10, 0, 0. The angular momentum at point G is going to equal 0 because every time you do the cross product of two values in the same axis, they cancel out and equal 0. So that's that. Now we go to point H. In point H, the distance is 4 in the positive x-axis and 3 in the positive y-axis. So 4, 3, 0, cross product 10, 0, 0. Now using the formula for the cross product, the x-axis would be ry times pz, which is 0, minus rz, which is 0, times py, which is 0. For y-axis would be rz, which is 0, minus rx times pz, pz equals 0. And the z-axis would be rx times py, which is 0, minus ry times px, which is 30, which gives us 0, 0, negative 30 kilograms times meter squared per second.